So today we are going to just look at a very simple design as a tutorial class to encourage you to practice some of the things we've already learned in the previous classes. And we have already gone through a lot of the videos and issues on computer graphics. So today we are going to go through a simple example which you will complete on your own. But I'm trying to situate this example so that you can at least see what makes it necessary for an engineer to do computer graphics or three-dimensional solid modeling. So I'm going to take a very personal thing, something I'm doing right now, and to just motivate you to see how, as an engineer, the way you can use graphics to communicate. That is what we're trying to do. An engineer, how does an engineer communicate? An engineer speaks graphically and quantitatively. I want you to allow this course to define what you are as an engineer in the way you communicate. I will take you through a personal example to guide today's tutorial class. And it is to impress in your mind the importance of the ability to communicate graphically. Your mathematical courses will deepen your ability to communicate quantitatively. So when you mix the two together, an engineer communicates graphically and quantitatively. We are going to emphasize graphical communications today. Sometimes an engineer communicates with other professionals. You speak to an architect, a roofer, a builder, a draftsman, somebody in the workshop, foreman, and so on. A layman communicates qualitatively and vaguely. When you're a layman, you say, okay, please let the house be a bit tall. Let the table be big. An engineer will say, let the table be 2 meters wide. That's different from big. That is quantitative. And then if you want to give information to someone, if it is going to be something to be built, you are going to draw something. And the question is, why can't you take a picture of that thing? Well, sometimes the thing may not exist. It may exist only in your mind. If it exists only in your mind, even Apple has not yet designed a camera that can take photograph of what is in your mind. So that has to come out through a three-dimensional solid model of what you have in mind. And you will see, we will discuss other reasons why photography is not enough, why photography is not sufficient before we finish today's class. But just know that an engineer communicates graphically and quantitatively. An engineer is distinguished by his ability to be specific in details. I want to start by just showing you a building that I was trying to construct 3 years ago. And here, the 3D solid model of a building I was trying to do 3 years ago. It is in the original design as a brief to the architect. So this is my own idea of what I want the house to look like. And this was sent to the architect. The question is, if I can draw it, why do I still need the architect? The fact that you can draw as an engineer doesn't mean that you are an architect. An architect can put fine details, fine architectural details of a building that an engineer cannot even think about. But your drawing can give the architect an idea of what you have in mind. An architect processes that and can make suggestions to you as to what you ought to do for the building to be architecturally sound. That is how two different professionals can communicate, and that's what I want to show you. I will take you through the Fusion 360 drawing of this. I'm just showing you the typical drawing because I want to lead you to a problem that we will need to solve by communicating graphically. And we are going to go through this, creating the diagrams in 3D solid model today. So this is the original design from my own mind. This is what went to the architect. Beginning with this brief, the architect used his experience to make additions or deletions for a properly designed building. So the architect started from here. What is important here is that in this building, there's a central courtyard which is designed to bring in fresh air and rainwater. The idea is for good ventilation and lighting in the building. So that's we're going to concentrate on that. I will give you more details as to why some things are the way they are when we look at the drawing inside Fusion 360. It will be clearer there. Okay, so let us now define the problem. Architects and modifications. From the architect standpoint, the roof structure became higher, and his argument is that for aesthetics and to avoid roof leakage, it should be higher than I thought. So the center of the building now rose to 8 meters tall, nearly 3 stories for a bungalow, which is surprising to me. And you'll see that there's an observatory 6 meters up, creating a cage that shuts out light so that I can use the telescope to do some things. And then there are terraces, and there are holes trapped in the roof air so that we can use an extractor fan to remove hot air to make the evening cool, for instance. Now, let me define the problem. This is now a photograph of the center of the house. This is a photograph. This is the upper terrace, and this is the part opening to the atmosphere. There is a small, satellite dish there, and then there is a staircase here. There are some wooden planks there. This is one of the holes that you can put an extractor fan to bring out air. So if you look up, you see the picture on the left. If you look straight or downwards, you see the picture on the right. The picture on the right, you can see the floor, you can see staircase, you can see the staircase, or not staircase now, the ladder that leads to the small through which you can enter and go to the upper terrace. And this is just the house. Now, there is an unforeseen problem here. And this problem has to be communicated to a roofer for a solution. So I will present that to you. You will draw it, and then you will propose solutions. And by the time you go home, and then we'll discuss that when you come back. And we are going to speak to each other graphically using 3D solid modeling that will start today. The problem is that water coming from this open space hits the floor and then spills onto the walkway around that center place. So the water hitting the courtyard floor bounces up to the walkway, and in heavy rain can become a nuisance. What is the simplest way to solve this problem? In order to describe this problem to a roofing professional, I need to make a 3D solid model of the courtyard. So another thing, there is a drilling here on the wall to put those two, I drilled several holes on the wall to create a raised platform using strong wooden beams. These are the preliminary holes, and these are some tools used. And then here is the mason trying to bury the beams inside the wall and finish the rendering. These are some things that were done over the weekend. So from this one now, we can put a platform here and can reach some of those high places when we want to do some stuff there. So this now is the 3D solid model of the courtyard. Here you have the pillars, 1, 2, 3, 4 pillars, some from the floor to the lintel level, another one very tall to the top of the roof here. And then these are the 2 wooden planks that are placed on it. So here is the same space in 3D. I've showed you the space in a photograph. Can you tell the difference between a photograph and a 3D solid model? What is it? The questions I will ask you now, which I will ask you to go to the chat room and answer. What is it you can do with the solid model that you cannot do with a photograph? I've started answering that question. I want you to tell me, before we go ahead and do this 3D solid model in class, what are the things that make it necessary to do a 3D solid model and not just simply take a photograph? What can you do with the 3D solid model you can't do with a photograph? So I'm waiting for you in the chat room. I want you to tell me what your answers would be. I have some more answers at the end in some slides further down, which you will see later on. Okay, you can observe more. Yes, but that's still vague. Specifically, Manuel Shudipo said you can observe more details. What else can you do with the all views? Can you do it a 3D solid? Why do you need a 3D solid model when you can just take a photograph? We view the model in different planes. Yes, that's what Muyiwa, Emmanuel Officer, that's what Muyiwa just said. Okay. Let us just take a look at the model. Let us go to the Future 360 aspect and just a look. For example, this is the model that I have. I can take, now I hope, admin, can everybody see my 3D solid model Future 360 page now?
Yes, sir, it's on now.
Okay, good. So you can pick the orbit here. You pick the orbit here, you can rotate this. That's the view from the top. You can look at the view from the bottom. You can look at the view from the side. You do not need to use the orbit only. You could also you could also go home and take a view from the front, or click from the top, click from the side, and so you can look anywhere. That is one thing that you can do. So this is the full picture. We can take a look at this, but what we are going to do before I provide my own answers, let us even look at the building itself as I proposed to the architect. You could also take the whole building. If I want to look at the foundation, I can take the orbit and just look at the bottom of it. This is the foundation. This is looking at something. You cannot do this with a picture. I'm looking at it from the bottom. If I decide to open this up, you can see how a pillar looks like. You can see the reinforcement. You can see the reinforcement rods inside the pillar. These are the reinforcement rod 1, 2, 3, 4. If you expand it, you can see it more clearly. If it is too big, you can go back home and take another look at it. And not only so, you could also do animation. For instance, when you have sliding doors or opening doors, you can actually make them slide and see whether you are happy with the sliding. Because this drawing is very complicated, I want to show these things to you in other graphics. For instance, take this chest of drawers. This is actually a physical drawer inside my room, and I can draw it in 3D solid model, and I can decide to open and close the door here. I can open and close this drawer. So the kinematic constraints of the drawing can actually be demonstrated and shown in the 3D solid model. So you can open and close. So you can do that. There is a lot you can do with the solid model animation, but that's not even the reason why you are doing 3D solid model. I will show you the bigger reasons shortly. So what we are going to do now is we're going to see how did we create this drawing to start with? How did we create this drawing? This is a very simple drawing. We will start with this drawing today, and we will use the graphical user interface to create it. After we have created it using graphical user interface, and we have used the same graphical user interface to do a number of things, we are now going to use Python software, Python programming, to write code to also create it. There are two windows to the graphics engine that you are using. One window is the graphical user interface, where you put down icons and you create stuff. The other window is the programmatic window, where you write Python code and you create the same thing. And before you learn about the Python, you first of all have to master how to create the thing ordinarily using the graphical user interface. So let's go to the slides and then we'll take it one by one and I will execute it until we get to a point where you are sure you can continue on your own. So I want to begin with the, okay, so I have written here a list of things that you can do with your 3D solid model. For to create you can use 3D. What are the inputs to build the building? The kind of work that what do you call them now? These people that quantity surveyors do. The 3D solid model can do it much more efficiently and more accurately. Even when you make changes, it will change the building, the bill of quantities for you. You could also look at the strength of different portions and compute, say, reinforcement and other sizes for a stable building. You can decide, you can look at the weight of a wall and then change the thickness of the cement blocks so that you can see the difference in the weight and see whether the beam that is carrying it is strong enough to carry it when you make adjustments to the size without building anything. The whole training of an engineer is that you don't wait for a building to fail. You do the drawing, you do the analysis. If there's any failure, you will notice it at the design stage, not at the construction stage. For instance, you have a tower, like there is this center courtyard now. It's a tower of some sort. There could be wind loading and other loadings. You want to check, if you put in a particular amount of wind loading, you want to see whether the reinforcement you have put is good enough to make the building stand. And then you can go into simulation. All these things you cannot do with just a simple photograph. In addition to the fact that your photograph can only photograph what exists, it cannot photograph what is in your mind. Whereas you can bring out what is in your mind in a 3D solid model. Okay, so what we are going to do, we are going to start this building by creating a sketch. We create a sketch to get the first 4 pillars out. So we create a sketch to get the 4 pillars, and it will be 110 millimeters by 110 millimeters. It is it's an error here to say 11 by 11. It is 11 centimeters by 11 centimeters. So it's 110 millimeters by 110 millimeters. So you dimension the center to be 1,800 from the origin, and then double duplication, end sketch, and extrude 4 new bodies. So at the end of this set of instructions, you are going to get your 4 lower pillars. So let us go and do that now. Just obey these instructions and get the 4 lower pillars. Okay, so go to Fusion 360 here. So I want to start a fresh drawing. So what I do here, I create a sketch, create sketch. And when you create a sketch, the first thing you have to do is to select the plane, because immediately when you say create sketch, Fusion 360 gives you 3 perpendicular planes. So you select one of them to create your sketch in. So I'm going to choose the XY plane. And once I choose the XY plane, I am given the XY plane like this. And then I can make it the way I like. Now, the next thing I do is that I create a center rectangle. The center rectangle occurs as an icon in the applications menu. So I take that, I create a center rectangle here. So if I create a center rectangle, and that center rectangle would be 110 by 110. So sorry for that. Okay, so that is the center rectangle. That's going to be the position of a pillar. So the next thing for me to do is to decide the distance from here to the origin. The distance from here to the origin is going to be 1,800 millimeters. So I take a dimension from the center of the pillar to the origin, and I would say let that be 1,800. So once I'm happy with that, I take another dimension in the other direction from the center to this place in this direction, and it is 1800. So with that, I have a pillar that is 1800 from in both directions from the origin. So, but there are 4 pillars, and this is the center. How do I get the remaining 2? There are several ways to do it. I can use pattern replication. I can use mirroring. I decided to use mirroring for this simple case. So I can create a mirror at the sketch level. So I create a mirror by choosing the mirror icon. And then it wants me to select objects to mirror. It is what I've created here. That's what I want to mirror. And it says 11 objects selected. That is all the lines around that rectangle. So it wants me to select a mirror line. So I want to select a mirror line. The easiest way to select a mirror line is to go to the browser. When I'm in the browser, I turn on the light of the origin. Once I turn on the light of the origin, I'm interested in mirroring along the y-axis. So if I pick the y-axis and I say, okay, you can see that what I've created just now, this pillar cross-section has been mirrored to the other side. I can do that once again. I can mirror both of them along the x-axis to this other side. So I can create mirror again, create mirror. I select this one, and I select this one. And then the next thing is to select the axis, select the mirror line, and this time I select the x-axis. So when I say okay, so you can see I have 1, 2, 3, 4. I've created the 4 cross sections. Now obstructed. I say finish sketch. The sketch is done, and I can go back to the origin. I can go back home, and now I'm able to create the pillars if I want. I want those pillars to be 2.5 meters high. So I create extrude. I create extrude here, create extrude, and I have to first of all select the profiles to extrude. This is one profile here. This is second profile here. This is another profile here. And this is a 4th profile there. So I've decided to extrude 4 selected profiles. The next thing is, where is it going to start? It's going to start the extrusion from profile plane. It is possible for me to start the extrusion. Extend type is distance. I can use, you will see that it's not the distance I can use as extend type, but this first one, let us just use the distance and let the distance be 2,500 millimeters, 2500. That will be 2.5 meters. And then what else am I to choose? Taper angle, I'm not tapering. Operation, new body. I can create new body or new component. I can create, for this first one, let me create new bodies, and then later on, I will make them components. But from this time on, I will just create new components straight away. So let me just choose to create a new body here. When I've selected all those things, I press OK. And now you have the 4 pillars. The 4 pillars have been done. Here are the 4 pillars. So these are the 4 lower pillars, as stated in the list of things to do. So that is the bottom of the courtyard building. We have done it by doing a simple sketch and then extruding the profiles that have been designed to hold the pillars. Okay, so let's go back to the PowerPoint presentation now. So you can see that we can create a sketch here. So we have gotten this result now by creating a center rectangle 110 millimeters by 110 millimeters, then dimension the center to be 1,800 from the origin, double duplication, you duplicate with y-axis, and then the original picture and the duplicate, you duplicate both of them along the x-axis, making a double duplication. That is how you turn from 1 to 2, and from 2 to 4 profiles. And you can make your extrusion pillars out of them. So you extrude 4 new bodies. So now the next thing is to make components out of bodies. The last step created 4 new bodies. We will make pillar components out of them one by one. To do that, you go to the browser, select each body, right-click and find the menu, create components. You will see a menu there. Once you select, when you select each body and right-click, you will see that you can do some of these things. Once selected, a component is created with the default name. You can double-click, see it when we do it. You can triple-click on the name to enter your preferred name for each component as you create them. So let us go back again to the Fusion 360 graphics, and then let's continue from where we stopped. So you see here on the browser, this is where all the bodies you have created are located. You can see all the bodies there. So if you expand this arrow, you will see that it has body 1, body 2, body 3, body 4. What you can do, if you click body 1, and you say, okay, sorry, I have to first of all remove my orbit. I was orbiting before. So if you click body 1, you can see body 1 is marked. If you click body 2 is marked. Click body 3 is marked. Click body 4 is marked. But what you are supposed to do now is not just clicking, just right-click body 1. If you right-click body 1, what you see here, you see create components from bodies. If you select that option and you click it, immediately body 1 is no longer in the list in the browser, but it has become a component 1. You can go there now. If I double click, nothing happens. If I triple click, if I click 3 times in succession, I am given the option of now labeling that new body the way I want. It is called it component 1. That's not a very good name because you are going to get, let us call it pillar 1. You can call it pillar 1. If you go and do the same thing on body 2, right click, create component from bodies, and then triple click, you call it pillar 2. Go again to body 3, create component from bodies, then you triple click, you call that pillar 3. And lastly, you go to body 4 and you right click, create a component from bodies, there's a color there, and then you triple click, you call that pillar 4. So with that, we have gotten 4 pillars. In order for Fusion 360 to tell you that you have finished making them components, it puts each of them in its own unique color. When you see these things in their own unique colors, you know that they are separate components on their own. It's very good to have these things as components. When you have them as components, you have far more facility with them. You can apply materials. For instance, you can say that this is concrete. You can say that this is made of wood. You can say, and if you do that, if later on when you are testing the strength, it takes all the properties of wood that is already in its database and it brings it to your usage at that point. So you are able to do some of those things to components that you have created. You can also create opacity, which we will look at later on. So with this now, we have created the 4 lower pillars. So the next thing we're going to do is to create the upper pillars and create the wall that surround these pillars create the walls that surround these pillars. So let us now go to the PowerPoint and see what instructions we are given to follow. Okay, so the last step created 4 new bodies. We will make pillar components out of them. We have done that. You go to the browser and select each body, right click and find the menu, create component from bodies. We have done that. Once selected, a component is created with a default name, component 1, component 2, component 3, component 4. You now triple click on that name. If you triple click on that name, you now have the option of typing in any name you like. And then you can now double click. No, it's not. This instruction is wrong. It's triple click on this name and enter your preferred name for each component as you have created them. So we have done that. So the next thing we want to do at the upper level, we want to create walls and upper pillars. There are walls and pillars. So there will be 4 walls and 4 pillars, 4 more pillars. So this is how you do it. You create a sketch on the cross-section edge of any pillar. For instance, this is a cross-section edge here. This is another cross-section edge. This is another cross-section edge. You can use any of them as a starting point, and you join the outer edges together. If you join the outer edges together, you are going to have a closed curve, and that closed curve is very important. And then from there, you are going to do some offsetting, and after the offsetting, you will be able to create your walls and your fresh pillars. Let's go ahead and do that now, going back to Fusion 360. Now we are back in Fusion 360. So the first thing to do is to create a sketch. You create a sketch, and as usual, when you create a sketch, the first thing you need to supply is on what plane do you want to create the sketch. We can choose any of these planes. Now we can choose the plane of any of the top planes of the pillars will be good enough. You can choose any of them. So I decided to choose the one with green. So with this one, so what I want to do is to join the outer edges of these pillars. I can join the outer edges of these pillars with straight lines. So I create a line, and then I select the outer edge here to this one, to this one. If you are in doubt, you can make it very big so that you can be sure of what you are doing. And then okay. So in order for you to be sure that you have done the right thing, you can see that it creates, for me, some bluish background to show me that what I have there is a closed curve. But there's some error here now. So let's just go and see. It looks as if there's an error, but let me just be sure. Let me be sure. So yes, as surely there's an error. So this is something you have to be careful of. You can see that here, it's not coinciding with this point correctly. Neither is it coinciding here correctly. So I want to go back. I want to escape from what I've just done and redo it. Okay, so let's start again. So we shouldn't be in a hurry here. So because when you are in a hurry and make some terrible mistakes, and when you make a terrible mistake at the beginning, sometimes it can be very difficult to get out of it. Okay, so we are picking a line. I want to start from this edge here. But because this drawing is very small, you can make it very big to be very sure that you are accurately picking the edge. So you can see I'm selecting this edge now. That is my starting point. So I will make that small. And I'm going to this edge. When I get here, I will make everything big again and be sure that I select the edge accurately. Okay, so going here, I make this big. I want to select this edge accurately. Okay. I want to select this edge accurately. Then I want to close it here. Select this accurately. And I think I have everything correct now. So okay, so you can see that here I have everything in everything that I've selected now in blue. So the next thing I'm going to do is to select an offset. In an offset, I have this closed surface here. I have this closed surface. I want to select an offset. A much faster method, and there is an offset icon here. I choose this offset icon, and then I select the profile I want, and I want to offset it by 110 millimeters. I've selected it. So that is better than selecting it one by one and doing a line through. So I have two profiles now, and you can agree with me that inside the walls I'm looking at are between these two profiles. But there's one more wrinkle to what I'm supposed to do here. It is that I could go ahead and finish my sketch here, and I go on and do the walls. And let us go ahead and do that. I can do an extrusion. I can do an extrusion here and say create extrude. And then I select this closed path. And I say that's the profile plane, one side dimension. Let us say I decide to use 5.8 meters. If I do that, oh no, I didn't get that right. So let's see. Oh, no. I need 5.8 millimeters, which is an error. So I can cancel what I've just done with a Control Z. Control Z cancels the last command that I issued. So I create again, create extrude. I select this inner space, and then I choose a distance of 5.8 meters is 5,800 millimeters, because millimeter is what I'm measuring in. So, and I'm selecting a new body. So you can see here, you can see this. Now, this, as far as the drawing is concerned, it looks okay. The only thing left is that if you look at this edge here, let me use an orbit to show you. You can see this edge here is the only thing missing. And I can easily put a pillar here. I can put a pillar here and say, let there be a pillar, I can see, or to make it up. But that's not going to be right. The correct thing to do is to go back again to the origin. And at the origin, I want to remove what I did before. We can edit that drawing, the graphics the sketch we did before. We can use a right click and say edit sketch. This sketch is not complete. What we need to do is to make sure that the profile for the pillars are excluded from the profile of the walls and the beams. To do that, it's very easy. To do that, we can do what is called an extension. We can extend this line we can extend this line beyond where it is to join this line. If we extend all our lines, we will see that all the pillar areas will be omitted. So I can choose modify, extend, and once I extend this line, if you look carefully, you'll see that there's a red finish in there. If I click it, it has extended that line. If I also try to extend this one, it has extended that line. If I try to extend here, it has extended that one. If you look, just watch out for the red end there. It has extended that. There is one more extension to do. like for you, let me bring it to the center so that you can see it. So I can extend this one. So I have to select the extension again. Or do I say, yes, the extension is still there. I extend this line and I extend this line. So with that, I'm able to create my beams without any problem now. So what I'm going to do is I say finish sketch. And I'm going to create the beams along these lines. So create extrude. Create extrude. And I'm going to select the profiles. This is one profile. No, that's not it. That's not good enough. I've not finished my extension. So let us extend one more. Extend. I can extend this and extend this. Okay. So with that, finish sketch. So let me now create my beams. I can create an extrusion. This is one beam. This is the other. This is another beam. This is another beam. And this is the last beam. You will notice that in this case now, we are creating all these beams and we are omitting the pillar profiles. So the beams are separate from the pillars. So I've selected four of them, and I am extruding them to the distance of 110 to make the beams, no taper angle, and I can create new components. Let's say okay. Again, these are now, so it puts all the beams as a single component. If you're happy with that, we can leave it at that. If we're happy with that, we can leave it at that. But if we are not happy, we will go back and create bodies so that we can have different beams. We want to distinguish between this beam and this beam and this beam and this beam. And the reason for that is that if we don't distinguish them, later on, when we try to use this surface, it may take all the surfaces as one, and that will not be good. So I'm going backwards again. I'm going to create this thing one by one. I want to create extrude. I want to create this, and it's a new body and a distance of 110, 110. And then it says, is it a joint or a new body? It is a new component. It's a new component on its own. And if I'm happy with that, that is one beam. I'm going to do the same thing over and over. I'll go back to I can go back to the drawing. I can go back to the sketch, and I can say edit sketch. And I can create another one here. I can create an extrusion, or I can create a press pull, which is another way of creating it. And that press pull, which I can do from my editing menu, it is basically the same thing as the extrusion, and I'm going to 110. And from there, I'm creating a new component instead of joining. That is a new component. And we can see that if we look further. So this is, we have one beam, we have another beam. I can go back again to the sketch and edit sketch, and I can decide to choose this, and then right click to do the extrusion, and then take it on one side, 110. That's the distance. From there, I don't want a joint, I want a new component. Once I'm happy, I click OK. And lastly, you can't see it now, but it is there. And lastly, I can choose this one. I can do the editing again. I can choose this last one and press pull here. And what am I going to do? I'm going to do 110 millimeters, 110 millimeters. And if I want a new component, I can go and look at all I've created. Okay, so you can see now we have 4 pillars and 4 beams at this level, and then if you take a very close look, you can see that we have the space for increasing the pillars completely untouched. So the beams don't intersect with the pillars, so we can go on from there. Okay, so let's see. Please, if there's any question here, you can go to the chat room and ask it. If not, I will continue. What I'm going to do next is to extend the pillars up and then create the walls, both up and down where they exist. If there are no questions, I'm going to come here and extend this pillar up. And I do that as new components for all the pillars around. But before that, it may even be nicer to create the walls. So I can say create extrude. Let's see if I create this one as a profile and create, okay. If I create that, and then the distance again, this one now, let us say 5,800. 5,800. And I'm not joining, I'm creating a new component. Okay. So let us see what it feels like now. So you can see we have 2 beams here. We have 2 pillars here. We have a beam and we have a wall. We can do the same thing all around. You can do the same thing all around. If we do this thing all around, and then let me just create one more pillar. Once I've created one more pillar, I will take you to how it will look like. So I will create a high pillar. Now, before we go on, we can remember that we can rename all these things one by one. Rename beam 1, beam 2, beam 3, beam 4. And then now we can rename wall 1 instead of just component 9, component 10, 12, and so on. We can give names that will help us remember what we were doing. So if I want to create the upper pillar, again, I can come here and I can create an extrusion, and I will just make this big. So it is this profile plane I want to extrude from. I can manually extrude it, or I can, another thing I can do, I can say that the other side, instead of using distance, I can say to object. Instead of using distance as the limiter, I can say to object, and I do it until this object. Oh, that's not working. So let us use the distance. We'll see where the object will work later on. I want to use distance. The extent type is distance. And let us take the distance of 5,910. 5,910. It's okay. So you can see that we have created this. Oh, but let me edit that because it is telling me it's of the same color with this. It might have joined that to become a single component with the previous one. So I want to edit this feature. Instead of join, I want it to be a new body. So it wants to be a new body. Let us see whether I have that as a new body now. So this is a new body. So we can go on now and create another wall here and a pillar, wall, pillar, just the way we have done. If we do all of that, we're going to arrive at this kind of result. This is the result we will arrive at. We'll create this pillar here, this pillar, and then this wall, this pillar, and then wall, pillar, and wall. We have only created this pillar. There's a pillar here. Let me just use the orbit to look at it. There's a missing pillar here. I can come here and create a pillar here. I can come and say, create extrude, and then I choose this face, and then there is a pillar that will go up there, and I can choose what distance it will be. I can do it manually by dragging this to the height I want it to go, or I can type the figure. I can say, well, this is 5600, 5600, and that will be it. So that is the pillar. So wherever there's a missing pillar, there's a mistake there, I joined instead of asking it to be a new component on its own. No, I don't want a join, I want a new body on its own. So it's a new body. Okay. So that's the difference. So we can again use the orbit to move around and take this place and get this edge and make the pillar there and so on. So if we do that, we can just continue along that. And I keep checking my chat room to see if there's any question. No questions so far. All right, so that is that's how it is here. So we can, but let us see this particular drawing, because this is one drawing that I want to take a look at. Let me see what that feature was created. I want to correct that. Let me show you how this particular one was created. This is an example of a situation where the height of the extrusion is not dictated by a figure or dictated by another object. In order to show you how it is done, I'm going to do another wall here, which I will remove later on. I want to do another wall here the way I did this wall. Now, I can create an extrusion, create extrude. Now, the first thing it wants is where's the profile? Where's the profile? It says once selected. I've not selected anything. I want to select, this is the profile I want. I want that profile, and I want a wall to come out of that place. Now, I do not want to select select how far it will go by distance. I want to select it by object. I want it to come from here and stop at the next object it sees. Now, in order to do that, let me do an orbit so that the face that is going can be seen. Okay, that face is seen now. So with that orbit, I can see the face, and I'm telling it that I want it to be an object. And I will now take this object to be the object to extrude to. So, and I want to be sure that it is not a join. I don't want a join. I want it to be a new component or a new body. Or let's see, a new body. I'm getting an error. Let's see why. I want to choose the orbit again. Let me make it big. I want it to go not through the distance, but through to an object. Okay, so let's see. So you can see, we created this wall by beginning from the surface of the pillar here, but instead of specifying the distance between the two pillars, we say start from this face here and end at the face facing it on this other pillar. So in that case, you use the object as the delimiter of how far your extrusion will go, rather than a distance. So that is something I just created to explain to you how this was created. So let me remove that, because that's not part of the drawing. Control Z. So I've removed that. The next thing you want to see is the window that is on this face. To create a window, you need to do a sketch. To do the sketch, you can come here and create a sketch. And we want the sketch to be on this face. Okay. So if it's on this face, we can create a two-point rectangle. So create a rectangle. Here we have a 2-point rectangle. And that 2-point rectangle starts from somewhere here. You can measure it accurately. And then it goes to a place here. This is the kind of distance it has to be from the lintel level to this point. So if I'm happy with that, I say finish sketch. Now, how do I create this window? I create the window by another extrusion. The extrusion that is going to happen here now is going to be a cutting extrusion. We're going to cut through this wall and make a window out of that cut. So create extrude. In all the other extrusions we have been creating made bodies. This is a case where an extrusion is going to cut bodies. So create extrusion. And then we select a profile. This is the profile. And then there are several things we can do. We don't need the distance. Of course, I know that the distance is 110, so I could have just chosen 110 millimeters, and it would be correct. On the wrong side, so I would say minus 110. Let us see. Minus 110, cut. Okay, so it cut it open. So that is the window we are looking for. Because I know that the thickness of the wall is 110. But suppose I did not know. Let us cancel that. Suppose I did not know. I can still do it. I can create that extrusion. I can create extrude. I create the extrude here. And then instead of the extent type being a distance, I can say it is to our object. I can say it's to object. And I do this orbit so that I can see the back of this place. Okay. Now, I can see to this one. And as long as I choose that it's a cutting extrusion, once I say OK, it has cut it. You can see this is much more satisfying than having to know what the distance is. If there is an object already, so I am starting an extrusion from this profile plane. I want to do it to the end, to the other side. So all I need to do is to choose the object of the other side. Once I click any part of that other side, that extrusion will take place. And if you go to look at our drawing from the slides, let us just see what else we have to do. The two things left to do is to draw this upper terrace and these two wooden beams. So let us look at the upper terrace. The upper terrace is a little bit harder to do. It requires some additional technique to do it. There are several things you can do. You can sketch anywhere and offset. Okay, so let us just try and do a sketch and offset before we do the terrace. Go back again to Vision 360. Let's see what we are doing for time. Wow, it's already 5 p.m. We started at 4. Class, I think it is time for our break.